Today we're back with another Klipper video. We're talking about bed leveling one more time, but this one's all about Z-tilt. Hello everyone, Chris here. We've done a lot of videos over the years on leveling your 3D printer bed. Remember, that's not level to the ground, that's level to your print nozzle. Now, we did a video a couple of weeks ago on Z-probes and everything Klipper can do to use that to level your bed, including how to get it all set up. In the mix here is something called Z-tilt. Now, you can use Z-tilt with other types of bed mesh leveling if you'd like, but on a lot of the newer kits, we already get a great surface to print on. It's nice and flat, so you might not need that extra bed mesh. Z-tilt should be all you have to do, like on this Trident right here. Now, it is a pretty impressive feature. I like to use it whenever I can, but you do have to have multiple Z motors to make this work. So today I'm going to show you how to set all that up, what it does, how things are configured to use those multiple motors here in Klipper, and hopefully this will help you out if you want to set this up. Now remember, go back to that Z probe video. I'll leave a link in the description below on how to get everything set up with your probe. This is just an add-on feature to implement that tilt. So let's get into it. So first off, what is Z-tilt and why might you want to use it? So on our Trident right here, you can see we have 3 Z motors. We've got the 2 in the front and the 1 in the back. Those 3 motors make a plane so that you can adjust this accordingly. Now, you could use 4 Z motors if you wanted to, but you run the risk of those motors fighting each other when it's trying to do something like this. It's much easier to control just the 3 in this configuration. Now, we really don't have to worry too much on the Trident or the Voron kits that I've seen with these bed plates. This was a pretty thick piece of aluminum. We don't have to worry about it being skewed. We don't need a bed mesh necessarily. It's nice and flat. But if the machine powers off, if you lose power to one of your Z motors, there is always a chance that the bed has dropped on one motor or all of them. And you want to give it a quick check to make sure that it's completely flat versus the nozzle so you get a good first layer. That's what Z-tilt can do. And having the 3 motors makes all of this work. So it's able to probe different spots on the bed and then adjust these motors accordingly to flatten it out, and then you'll be good to go. So let's see it in action. I'm just going to skew one of these motors. So I'm going to bring one up, and then maybe let's go ahead and bring the back one down. Now, it's not a miracle. It can't compensate for everything, but we're fairly skewed here. The Z-tilt option is going to get you back flat, ready to print. So in your print start commands, all you would do is home. So you can G28, we'll just hit home all. Then after the printer has homed, all you have to do is run Z-tilt adjust. Now in Fluid or Mainsail, you can create a button to do your Z-tilt, but just to show you how it works, if you want to build your start G code, you'll see this a little bit later. Just in the command line right here, enter Z_tilt_adjust. And I'm going to zoom in a bit so that you can see the effect of the Z-tilt adjust. Pay attention to the bed frame here. When we do the adjust, after it probes, you'll see it flatten out. The sequence is running. We'll head to the first corner and we'll probe. Then we'll head to the back lead screw right in front of it. We'll probe. And then we'll head to the right corner to probe. And then watch it level it out. It's going to do it again. And it's going to do this until it gets into a tolerance that is acceptable. That's all set up in the configuration. We're going to go a third time because it's still just a little bit out of spec. It's still adjusting. And then after 4 times around, remember we purposely skewed this bed. It was pretty far out. We got within that tolerance that we set. Now it's 0.0075. And it's going to tell you all the different adjustments that it made for all the different screws. Now the bed is flat with the nozzle as far as the probe is concerned, and we're ready to start our print. Now remember, it's not going to adjust this much on every print. You're not going to skew it on purpose, but it is a great tool to make sure you're in that tolerance before you lay down that first layer. And just for fun, let's go back and take a look at a slow-mo view of it correcting that first skew. So if you're planning on building one of these printers with multiple Z motors and you're running Klipper, this is a no-brainer. You're going to want to go ahead and implement this, but there are some steps that you need to take to be able to utilize 3 motors and to get Z-Tilt Adjust to work. Remember, a lot of it is setting up the probe. A lot of that won't be in this video, but it is in the previous video. So now let's jump into Klipper and I'll show you how to get all this configured. As with most of my Klipper videos, we're going to head to printer.cfg. We'll go to Machine, and we'll find printer.cfg. Now first, we need to configure our 3 Z motors. You can probably find an example configuration where that's already been set up, but we're going to go over it so I can show you the steps that it's going to use Z-Tilt. We'll just head through the stepper section, and we have 3 Z stepper configurations. Now, the first stepper Z config is going to set a lot of the default settings for all the other steppers. So it is definitely the most important. You want to enter all the information for your board. The step pin, dir pin, enable pin. Again, that's probably going to be in an example configuration depending on what board you use. Today we are using an octopus board. Also the rotation distance for the screw that you use. It's very common to see TR 8x8s, TR 8x4s, or TR 8x2s. All that information can be found in the Klipper manuals. Go with the 4, 8, 2. It's pretty easy to figure out which ones are which. Just count the starts on the screw. Micro steps, we are using 32 here, but that will set how many steps that you need to rotate to do a full revolution. We're using 32 micro steps here. Full step per rotation is 200 because these are 0.9 degree steppers. At 16 microsteps, that'd be 400. 32, 200. I always go back to the Prusa calculator to figure out things like this. I'll leave a link to the calculator in the description below. Now, as far as Z-Tilt is concerned, these are the settings here we need to be concerned about because we need to know where those motors are positioned. So I've explained a lot about Z motors, and a lot of this you don't need to know. But what I'm trying to drive home here is there's a lot of different position settings for your printer in Klipper. You need to know which ones affect what. For Z-Tilt, we really don't care so much. We just know that we need multiple motors. These position settings here in the first motor, those are going to set a lot of the same things for all of the motors. Like position max, position min, that is the Z position. You don't have to set that on each motor individually. As well as things like homing speed, retract distance, how the probe functions with Z. We're just configuring the motor and then down below the stepper. The steppers are going to be pretty much the same. Stepper driver is what I'm referring to there. So we have our first Z motor. We've set the Z up already. We know that it can home. It's functioning correctly. Remember, we're just after Z-Tilt. And then stepper Z1, or the second stepper. You really don't have to tell it anything other than where the pins are, what its rotation distance is. They should be the same as the first motor. Not saying you couldn't use a different type, but you probably shouldn't. And then same for the third one. All those settings should be identical other than pin location. And remember, pin location is defined by the board. Again, you should have an example somewhere, but you could always figure this out yourself if you have the schematic or the pinout of the board. You can get those on most companies' GitHub. So we know all that. We know everything about Z. Now let's talk about tilt. And I've got my tilt settings down under Z Safe Home. You can pretty much put them anywhere under the Z motors that you like. I just put a lot of the additional settings down below. But regardless, if you have a bed mesh set or any of the other probing options, you can also add tilt if you have multiple motors. Really, the only thing you need to do is set where those motors are located so it knows the point to adjust from. And if we take a look at the Trident, your Z-screws are going to be outside the bed configuration more than likely. On the Trident, we have 3 again. We have one all the way over here on the left, we have one on the right, and then one in the far back. But we need to tell the configuration where those are. And I think that's the confusing part, is where do you actually need to tell the printer to go to do these measurements? Well, it's all based on the nozzle tip. So that's what's going to set the distance. That's your reference point of where the pivot point of the bed would be, not necessarily the screw location. So again, something like the Trident, we have a screw back here on the mount that actually allows the bed to tilt. It's got a shoulder like knuckle inside there that it can swivel side to side to allow this tilt to happen. That's the pivot point that you want to set in the configuration. And since the nozzle can't actually make it over there, you can get a rough estimate. It doesn't have to be dead on, but you want it close. But you need to measure from the center of that pivot point to the nozzle to get your measurements for the configuration. You can do that with a ruler, a set of calipers, but it'll make more sense if I show you the config and then we jog around to the different locations where those might be. And to keep everything correct in the config, you should list your points and your positions, like I'm going to show you here, in the order that we configured the motors. So we did left, back, and then right. So let's just take this first Z motor here, the one on the left. I've got it set to -50 and 18. These are a list of coordinates, X and Y, just in a list of all the motors. Remember, they do have to be indented. All this has to be set just like this for it to work. But that's where the nozzle would be if it could get to that rotation point, that pivot point, where the bed can actually move. So take into consideration where your printer homes, where 0, 0 would be, because then you're going to have to measure further than that to be able to get your pivot point. So we're just going to say here this front left is 0, 0. I would have to go out further in X to get to that pivot point. So I'll just throw my ruler up there. And the pivot point on the trident is actually just a little bit left of the screw back here. So I'll just give it a rough guess so I can show you here on camera. But remember, the nozzle is set to 0, 0. We're 50 away from that center point of that pivot. So that's why it's listed at -50x. And then for Y, it's the same thing. Remember, we're set to 0, 0 in Y and X. So if you measure back on the bed where that pivot point is, I'm about 18 millimeters away from the center of that pivot point, relative to the nozzle tip. And same for the second motor. We would just move to that position and get a rough estimate. So this is the back lead screw. There's the pivot point. If we move the print head over here, it's roughly in the center of the X of the bed. Remember, this is a 250 trident. But we'll just get it as close to that pivot as we can. It's quite a bit behind where the nozzle would be, so the Y is going to be a lot greater than the actual size of the bed. So that's why we have it set to 125x, 298y. So all that makes sense. You have to measure where the pivot point is. Now we have to set the points. These are the points where you can actually probe when you get to that position. So we need to move the bed by the Z position at the pivot, but we have to have a place to actually probe the bed to make those adjustments. And if you remember from the last video where we talked about setting up the probe, the trident has this square probe right behind the nozzle in the center, but it is back a bit. But we need to know where that probe is going to be when it starts doing this Z adjustment. Now on the trident, if the nozzle is at 0, 0, you can measure the difference of that probe where it would be in that position. We want to give it some room on the bed so we don't risk ever trying to probe outside the bed, because that will cause a crash. So just keep in mind where that probe is in relation to the nozzle. So in this view, it's directly behind. In X, we have to consider the size of the tool head. We're going to probe 30, just to be conservative, so we don't have any crashing. So 30 millimeters this way from 0, 0, not the pivot point. And then in Y, we can come up pretty far here on this printer, but we'll tell it 5 millimeters. Just again, to make sure there's no crashing. And we can take a look at the second motor as well, 125, 195. We're just trying to keep it inside the bed. So we're towards the back of the bed in the center position. We came to 125 because that's center X, that's where we want to be. But we only came back 195 because if we move back to 250, the probe is behind that nozzle. It's going to be off the bed. So you're going to have to play with these adjustments a little bit. The easiest way is to just get everything rough set up so it works before you define Z-tilt, and then just use the controls to jog the printer. So just use the controls that you already have at hand here on the dashboard. Just home all. Then just move your printer to 0, 0 to start mapping these out. I think that's the easiest way. You can just type it in here in mainsail, but we'll just do 0x, and then 0Y. So that gets us to the front corner, and I'll just show you what we had there in the configuration. Let's go 10 over in X. We'll take it all the way to 30. You can see where it is on the bed, and then we'll go to 5Y. That's what I had in the config. So that just shows you that you get a little bit of room there in between the edge of the bed to keep you on it. That's the easiest way to plot where you need to be, because the dashboard is going to report wherever you move to, and you can take those numbers and plug them into your config. Back to Z-tilt, that's all you need to get started. There are a few other parameters, of course. We'll jump down a little bit. You can set the Z-tilt speed. That's the speed of the non-probing moves. So how fast it gets to that point. You can go pretty high on a lot of these machines. The horizontal move, this is the height that it's going to tell it to move right before it starts the probe. So if you're getting early probes while it's moving, set this a little bit higher so it'll push the bed down lower, or however your configuration is. On mine, I'm pushing it down 10, making a move, then raising it back up. Retries is somewhat important if your bed gets out of skew a lot, if it's really far out. This is how many times it will try that probe point before it fails out. So if it gets a bad read, it'll give it another shot. And then the retry tolerance. How close do you need this to be when you do your Z-tilt? So it's going to retry that Z-tilt process like we talked about before if it's not within this certain tolerance. 0.075, that's pretty tight. But these beds, these machines can achieve it, but you might have to do it 3 or 4 times with those retries depending on how far it might have been out. So you might not need this type of tolerance depending on how big your bed is. You might not be able to achieve that. Again, this is a pretty low setting, but mess around with it. Figure out where your printer is going to work. Every configuration is going to be a bit different. But those are all the settings you need to set up Z-tilt. So when you've got all that set, you can just save and restart. And then to run Z-tilt when you need it to, you could always run it from the controls here in Mainsail or Fluid. By enabling Z-tilt, it should give you the button here on the dashboard just to run it. So after you're home, you can just hit Z-tilt to do that sequence. But on my prints, I want it to do it every print. The easiest way to configure that is in print start, or whatever you happen to call that macro. Mine is in the printer.cfg for this configuration. You can put it in a couple locations, but let's go take a look one more time. I'm going to scroll to the bottom. This is the print start macro. This is what runs every time I slice a file. I'll show you how that links up if you've never done this before. But I home, and then I just run Z-tilt adjust. Separated by underscores, that's going to run that sequence for you. Home one more time, then the printer will be ready to go. Now if you want to add bed mesh after this, feel free. You would just enter that bed mesh command like I showed in the previous video right underneath. Mix these up, and it will use them both at the same time. The only thing you need to make sure of, whatever slicer you're using, is that it calls that start print, or whatever you called your start macro, successfully in the G-code. In custom G-code here, this is going to inject this into your file. You see we have start_print. That's going to run a macro called that. You see how I have mine flip-flopped in this config? Print_start. That's not going to work if they're not called the same thing. So if you're having problems with that, that might be the issue. Doesn't matter what you call it, just as long as they're the same in your sliced file and in your configuration. And just one more thing, if you'd like to use tilt and a mesh, make sure you have the sequence correct. You need to realize that you would want to run your tilt to get a nice flat plane before you built your mesh. That might seem common sense, but make sure you have them in the right order. So to do them both in your print start, wherever you want to configure this, you would home all. Then you would run your Z-tilt. When the tilt is complete and it's happy with the tolerance, you can see it here in the console. It ran it a couple of times because, again, we skewed it. Then you would build your mesh. If you wanted to do it in the console, you can just run it from height map over here. But we'll just hit calibrate. Now it will run through the bed mesh, doing all the different probe points to build it, now that Z-tilt has already flattened out the bed. And there's our mesh. You can see it's pretty flat because we have tilt. It's a nice flat piece of aluminum. This should be more than good enough to print anything we'd ever want. Our range is around 200 micron. You could get it even flatter than that if you wanted to mess with the points, but that's how you would use them at the same time. And to bring it all together, if you did want to run both of those, tilt and bed mesh, just go to your printer.cfg or wherever you have your start macro and update it. We've got print start, we have our Z tilt adjust and our home commands. Right underneath that, we can put bed mesh calibrate, and then the profile we'd like to save that bed mesh as. And if you're going to run this on every print, on something like a Voron, you probably don't need to, but if you were to want to, it's probably a good idea to go ahead and clear it in your NG code for when the print ends. You can do that with the bed mesh clear. And that's all you need to know to get Z-tilt set up, even if you want to use it alongside your bed mesh. And there it is, everything you need to know to get Z-tilt set up in your Klipper configuration. Now remember, you do have to have multiple motors to use this, and it can be used alongside a lot of other options, like bed mesh if you wish. But on a bed that's really flat, a lot of these higher end machines, you really don't need to even build a mesh anymore. If you have a good surface to print on, just get those motors lined up. Maybe you had it powered off. Maybe things got skewed from the last print. It's really quick to run, and it's a great feature to add to your printer configuration. So hopefully you found this helpful. That's it for today, and I'll see you really soon on the next one.